As Director of Global Change Initiatives at the Science Museum of Minnesota, Patrick Hamilton develops projects that investigate the challenges and opportunities of humanity as the dominant agent of global change. These projects have included Water, H2O equals Life, an international traveling exhibit, the Big Backyard, the museum's outdoor environmental science park, Science House, the museum's net zero energy building, and Future Earth, an exhibit about how we survive and thrive on a human-dominated planet. New initiatives now under development by Patrick include Energy, which involves using the museum itself as a model of advanced energy efficiency, and Great Cities, a national traveling exhibit with complementary programming about how we make cities more livable for more people while reducing their environmental impacts. Away from the museum, Patrick and his wife Jay like to kayak and grow organic blue ribbon winning pears, peaches, and plums in St. Paul. Ladies and gentlemen, please welcome Patrick Hamilton.
Thank you, Shannon. Thank you all for being here. And first of all, I just want to compliment the City of St. Louis Park. You are really taking a leadership position on energy and environmental initiatives, and I think the whole metropolitan area is going to learn from what you're doing. You know, before I start, I want to qualify that bio because I was born and raised in Minnesota, and it's hard hearing that bio because you know, don't be showy, don't be braggy about yourself, and so I really want to qualify those rather bold statements about organic blue ribbon fruit. So here are the plums at the Minnesota State Fair with the blue ribbon. And here are the peaches on their way to the state fair where they got a blue ribbon. And here are the pears still on the tree before they got picked to go to the state fair where they got a blue ribbon. And here are the cherries. They got picked from the tree that never made it to the state fair because they make a great cherry liqueur. And nothing like a little taste of summer in the middle of the winter time. Well, when I'm not being an amateur fruit grower in St. Paul, I work at the Science Museum of Minnesota. And I develop environmental projects. And I've been doing that for a long time. And it's a great gig because I've been fascinated by the environment my whole life. I was born in Detroit Lakes. And growing up amongst the woods and lakes of west central Minnesota imbued me with a love of the environment that really has endured my whole life. Shortly after this picture was taken, my parents moved my three older brothers and myself to Moorhead in the heart of the Red River Valley. And that's where I graduated from high school. And at that time, I decided it was time to leave the prairie and pursue my studies at an Eastern university. So at the University of Minnesota Duluth, I majored in geography. And then I came down to the Twin Cities for graduate training, also in geography, where I specialized in water resources and climatology. And then I worked for 1 year at the Metropolitan Council back in the early 1980s as part of a very large team at that time grappling with what was then the big environmental issue in the Twin Cities, which was how do you manage the enormous quantities of waste produced by a large metropolitan area. And then I came to the Science Museum. I've been at the Science Museum for 30 years developing environmental exhibits on energy and water and climate change and other topics. And a wide array of issues, but the one thing that all of my projects have had in common is that they've always been partnerships, collaborations, whether that's with environmental learning centers or state agencies or increasingly with other science museums around the country. So they've always had that quality of partnership. And the most enduring partnership, in fact, has been with the University of Minnesota. And here's a quick story. So this is Effie Fufula. And she called me back in January of 2001. She and her colleagues, Chris Piola and Gary Parker, they were writing a multi-year, multi-institutional, multi-million-dollar proposal to the National Science Foundation. And they said, you want to be a part of this? Does the Science Museum want to join in? And I said, absolutely, sign us up. But as you can imagine, if you're going to write one of these really big proposals to the National Science Foundation, you better have a big idea. And they did have a big idea. You know, it was this, that rivers are absolutely essential to the physical, economic, social, and cultural well-being of billions of people on this planet. and geologists and engineers and ecologists and others, they've all been studying rivers for years, decades, centuries. But those individual silos of knowledge had never coalesced into a systematic understanding of how rivers actually behave, to the detriment of rivers everywhere and the billions of people that depend upon them. So what they proposed to do was to create a new synthetic science, and not by artificial, but a science that would synthesize, bring together the quantitative understandings of geology and economics and engineering and ecology. So they submitted this proposal to the National Science Foundation, and as you can imagine, it underwent months and months of review, enormous scrutiny. I call it the NSF spanking machine, because it just goes on and on. But we made it through the gauntlet, and in the summer of 2002, the National Center for Earth Surface Dynamics was established at the University of Minnesota, and I got to be one of the principal investigators. But my role was not to be a scientist, not a researcher. My role, my responsibility was to work with this team to help imagine and realize how they communicate their science, the research, the insights to big public audiences. And it was a great opportunity. I got to eat with these scientists, drink with them, travel with them, visit their research sites. And after doing that work for several years, I realized that I was hearing different versions of the same story from all of them. The geomorphologist said, "Do you realize that humanity is now the dominant agent of landscape change on this planet?" And the sedimentologist said, "Are you aware that humanity is now responsible for moving more earth and rock on this planet than all the rivers and glaciers combined?" And the ecologist said, "Are you aware that it's no longer possible to study an ecosystem on the surface of this planet without taking into account human influences?" So working with them inspired me to write my own proposal to the National Science Foundation. And it went through months and months of review. I too went through the spanking machine. But I made it through the gauntlet. And in the fall of 2009, the Science Museum in Minnesota established the Future Earth Initiative, the goal being to create an integrated suite of exhibits, films, and programs, all predicated on three main ideas. The first one is that humanity is now the dominant agent of change. We now dominate many of the chemical, physical, and biological processes that make this world habitable. The other key message of Future Earth is that this planet is now home to the healthiest, wealthiest, best educated, most innovative, creative, and connected populace ever. Which brings us to the third point, which is that's good because we need to innovate, and we need to do it now because collectively we have set in motion large-scale planetary changes. There are lots of ways in which humanity now dominates global processes, and I'm not going to exhaust you by enumerating them all. I'm just going to focus on three. The land, which covers 29% of the Earth's surface, the ocean, which covers the other 71%, and then the atmosphere, which envelops the entire world. So first of all, let's take a look at the land. So this is a data set that was created by the University of Minnesota's Institute on the Environment, and then the Science Museum of Minnesota converted it into this spherical projection. Everything that you see in green is cropland. This is the land in which we grow our corn, wheat, soybean, rice, sorghum, potatoes, all of it. And then here's another data set from the University of Minnesota's Institute on the Environment. Everything that you see in orange is pasture land, grazing land. This is the land in which we graze our cattle, sheep, goats, yaks, all of our domesticated animals. If you took all the grazing land on the planet and concentrated it on one continent, it'd be the size of Africa. So here we are. We currently use 40% of all the ice-free land on this planet to grow our crops and raise our livestock. And there's 7.3 billion of us on the planet, and there'll be about 9 billion of us by the year 2050. So humanity is now the dominant agent of landscape change on this planet. So now let's take a quick look at the oceans. I have lived my whole life in Minnesota, and living in the middle of a continent, it's hard for me to imagine that humanity could have much influence over the vast global ocean. But several years ago, a team of scientists worked together to create an integrated view of how humanity is now impacting the oceans. The darker the color, the stronger the influence that we're having on the ocean, particularly the bright red areas along coastlines where rivers deliver pollutants that have washed off the continents into the oceans. There are multiple ways in which humanity now dominates the oceans. Fisheries, of course, oil and gas extraction. But the most extensive way in which we are now dominating the global ocean is actually through our burning of fossil fuels. So every year, we are extracting billions of tons of coal, oil, and natural gas out of the ground. And then we burn those fuels, we combust them, we combine them with oxygen in the atmosphere to produce light, heat, energy. But the inevitable byproduct of doing so is carbon dioxide, which we allow to freely escape into the atmosphere. Now, about 20% of the carbon dioxide that we are releasing into the atmosphere is being absorbed by the global ocean. And the climatologists and oceanographers I talk to say, well, it's a good news, bad news situation. The good news is that that absorption of carbon dioxide by the ocean has actually been slowing or ameliorating the rate of climate change we would have otherwise seen. But the bad news is that when you take carbon dioxide and you mix it with water, you actually get a chemical reaction that produces carbonic acid. So the carbon dioxide that is dissolving into the global ocean is lowering the pH and increasing the acidity of the entire global ocean. So this is a process I contend cannot continue to occur indefinitely because 1 out of 7 people on this planet rely on the oceans for their primary source of food, for their protein. And it's hard for me to imagine that the oceans can continue to deliver that degree of service if we fundamentally alter the chemistry and therefore the ecology of the global ocean. So humanity now dominates the land, the ocean, and let's take a look at the atmosphere. So a little history here. So this is John Tyndall, a British scientist who made a remarkable discovery back in the 1850s. It was he that through rigorous scientific experimentation determined in fact that carbon dioxide does trap and retain heat in the atmosphere. And in fact, there's these tiny quantities of trace gases that actually play that fundamental role of controlling the flow of heat in and out of the atmosphere. A remarkably important discovery. So important, in fact, that this gentleman, Svante Arrhenius, a Swedish scientist, in 1896, 37 years after the groundbreaking research of John Tyndall, decided to do some additional research on carbon dioxide. Because he knew from John Tyndall that carbon dioxide is a heat-trapping gas. He knew that the world was burning increasing quantities of carbon dioxide. He knew that when we burn carbon dioxide, we were putting carbon dioxide in the atmosphere. So he decided on his own that he'd do some calculations. He would calculate how much the atmosphere would warm up if humanity doubled the amount of carbon dioxide in the atmosphere. And he was both right and he was wrong. And he was right in the sense that his calculations were remarkably good, given the fact that he did them by hand well before the advent of calculators or supercomputers. But he was wrong in the sense that he thought it would take 3,000 years for humanity to double the amount of carbon dioxide in the atmosphere. Because he did take into account the exponential growth of our burning of coal, oil, and natural gas. So the question before climatologists at the University of Minnesota, around the United States, or across the world is not whether putting enormous quantities of carbon dioxide in the atmosphere will change the way the atmosphere works. Of course it will. The question before them all today is where, when, and by how much? And increasingly the answer that we're getting is right here and right now. So this animation shows us 25 years of satellite imagery. We are looking down at the North Pole. Everything that you see in white is old ice. It's multi-year ice. It's ice that forms in the Arctic winter and then survives the melting of the coming summer and then refreezes the next winter and then can go through that cycle through several years before the ice gets spit out through the Fram Strait and melts as it goes down the east coast of Greenland. One of the big science stories of recent years is that the aerial extent of Arctic sea ice has been dropping dramatically. But what has been much less widely reported is that the actual volume of ice in the Arctic has been dropping precipitously. So what this means is that every summer now, a tremendous amount of solar energy is going into the dark Arctic Ocean that in previous decades was reflected back into space. Now it is a daunting calculation, a daunting computational challenge to figure out what that additional heat energy is going to do to the behavior of the Arctic Ocean and the atmosphere above it. But at its simplest, at its most basic, the global atmosphere, the global ocean, they're merely heat engines. And what I mean by that is that their behavior, their motion, is driven by differences, by contrasts in heat. And if you add additional heat to a heat engine, you inevitably alter its behavior. The changes may be subtle, or they could be profound. But increasingly here in Minnesota, we're starting to see rather noticeable changes in the behavior of the atmosphere. According to the Minnesota State climatologist, an extreme rainfall event is one that drops 6 inches of rain or more in 24 hours or less over 1,000 square miles. So these are not isolated individual thunderstorms, but big rain systems. And it's not that they've never happened before, because if we look back to the historical record of the 18th, 19th, and 20th century, they have occurred. But there's been this disconcerting rush of extreme rainfall events since the turn of the 21st century. For example, this was the summer of 2004, southern Minnesota. And 1 in 1,000 year rainfall event, according to the state climatologist, based on the enormous amount of water that fell out of the sky in the enormous area that was impacted by this storm. So a storm that should be exceptional in its reoccurrence. But this was the summer of 2007, 3 years later, another 1 in 1,000 year extreme rainfall event in southern Minnesota. Some locales got nearly 20 inches of rain before this storm finally abated. Rainfall of hurricane intensity. Lives were lost. Livelihoods were swept away. And then in early fall of 2010, 3 years later, another 1 in 1,000 year extreme rainfall event in southern Minnesota. So much rain fell out of the sky from the storm that the Blue Earth River, which flows north, went into flood stage. And it flows into the Minnesota River, and it dumped so much water into the Minnesota River that the Minnesota River went into flood, and the Minnesota River flows northeast into the metro area and meets up with the Mississippi River a few miles away from here. And it dumped so much water into the Mississippi River that downtown St. Paul hit its first fall flood on record, even though scarcely a drop of rain fell from the sky from this storm. Most recently, in June of 2014, Duluth and surrounding communities had their own extreme rainfall event. And streets turned into streams, and the damage to public and private infrastructure added up to over $130 million. So, humanity is changing the land, the ocean, and the atmosphere. And we're also changing ourselves. This is your world on Facebook. This is not Facebook put onto a map of the world. This is what you get when you take the GPS locations of millions of Facebook users and their Facebook friends, and you plot their locations around the world. You actually generate a highly detailed map of countries, of continents, of islands, with the exception of China, which doesn't allow Facebook. So as of the end of 2014, there was slightly over 7 billion people on this planet. But by the end of that year, there were already over 3 billion people on this planet connected to the internet, the global brain. And the forecast is just by the end of this year alone, by the end of 2016, half the world's population will have access to the internet. A remarkable growth in connectivity, but in fact actually dwarfed by what has happened with cell phones. There are now nearly as many cell phones on this planet as there are people. You may be living in a thatched hut with a dirt floor, but chances are, if you do not have access to a cell phone, you likely will in the very near future. There are over 400 million college graduates on this planet, more than the population of Canada, the United States, and Mexico combined. This planet is now home to the healthiest, wealthiest, best educated, most innovative, creative, and connected populace ever. Which is great, because we need to innovate. And we need to do it now in a wide variety of scales. And when I say we, I say especially us in the developed world, in the most affluent world. Because here's the situation. 10% of the most wealthiest people on this planet are actually responsible for half of the carbon dioxide emissions going into the atmosphere. Stated another way, if through some tragedy 90% of the world's poorest people were to disappear tomorrow, the remaining 10% would still be grappling with the issue of climate change and ocean acidification. So this issue is really something that we, those of us living in the most wealthiest parts of the planet, need to take special responsibility for. And we may not feel that we are rich, but here's just a quick mental exercise that you can try here or at home. So if you estimate your total annual household income after taxes, and just multiply that by 26, if you take your paycheck in your mind and multiply it by 26, and then divide that number by the number of people in your household, whether it's just you, or you and a spouse, or a partner, and then your dependents. If that number is more than $5,000 per year, congratulations, you are a member of the top 20% of the most wealthiest people on the planet. If that number is more than 18,500, you are a member of the top 5% in terms of income on this planet. And if that number is more than $34,000 a year, then congratulations, you are actually a member of the 1%. So we need to innovate, and we need to innovate across a wide degree of scales, from the personal to the global. So let's take a look at personal, and I'll get personal. This is the house that my wife and I live in St. Paul. And we've lived in this house since 1991. And I'm a data geek. I love collecting data, especially when it arrives in the mail monthly from Excel Energy. So this is actually our electricity usage over the last 25 years. This is the amount of electricity that the previous homeowner used, just slightly under 6,000 kilowatt hours annually. And through our diligence over the years, we've been able to reduce the amount of electricity used by this home by 2/3. But we still use electricity, and we still recognize the fact that how we generate electricity in the United States is one of the biggest contributors of free-traveling gases to the atmosphere. We burn a tremendous amount of coal in this country to make electricity, and that's extremely dirty. But there are options. So this is our utility bill just a month ago. We used 166 kilowatt hours that month, but we wanted to minimize as much as possible the environmental impact of the electricity that we did use, realizing that we've achieved, I think, is just about as much energy efficiency as we can. So we signed up for Excel Energy's wind source to get all of our electricity from clean, renewable wind energy. Now, I recognize the fact that if you do so, you do pay a premium. We paid an additional $5.86 the month of March to get all of our electricity from wind. But we thought it was worth it, and we could afford to do so. But if you sign up for wind source, then you don't pay the fuel cost charge, because no coal, no natural gas is being burned to create wind energy. So we got a credit of $3.81 on our bill. So it ended up costing us $2.05 for the month of March to get all of our electricity from wind, or about 7 cents a day. So wind source is an option that's available to you now, and increasingly we're going to see opportunities for you as individual homeowners, your businesses, your communities, to sign up for community solar, where instead of actually paying a slight premium for electricity, you could actually see a potential reduction in your utility bill. But let's also take a look at a larger scale, at the local, because here's the situation. So this is the neighborhood where my wife and I live in St. Paul, and that little red dot, that's our house. I'm all in favor of individual initiative, but we also have to recognize that we need to innovate at other scales. And here's the Science Museum of Minnesota. This one building uses as much electricity annually as every single household in that 18-block area of St. Paul. So we need to innovate locally, but we also need to look for opportunities where we work, where we go to school, where we worship, can also be much more energy efficient. And here's a quick story. This is Scott Getty. Before he retired, Scott Getty was a key account manager for Xcel Energy. What that means is that his responsibility was to represent Xcel Energy's energy efficiency programs to Xcel Energy's clients. And before he retired, he was responsible for representing Xcel Energy to some of the corporation's biggest customers: Hennepin County, City of St. Paul, University of Minnesota. But he'd always kept the Science Museum in his portfolio because he liked working with us on educational initiatives. And in the summer of 2008, he called me and said, I want to introduce you to someone who's achieving remarkable feats of energy efficiency. And that person turned out to be this fellow. He's a consulting mechanical engineer by the name of Dave Solberg. So I arranged a meeting at the Science Museum with representatives from Xcel Energy, the Science Museum, and Dave. And I said, so tell me, Dave, what do you do? And he said, well, I do exergy analyses of human engineered systems. And I said, well, I've heard of energy, I've heard of entropy, I've heard of some of these other terms, but I've never heard of exergy. What is exergy? And he said, well, it's simple. It's the amount of work that a system can accomplish as it comes into equilibrium with its surroundings. And I paused and I said, that doesn't get me very far, Dave. I'm not an engineer, I'm not a physicist, so what exactly are you talking about? And he said, well, here's an example. He said, the Science Museum. Science Museum uses a large amount of electricity. Electricity inevitably degrades into heat. We all intuitively know this. We take our phone out, we hold it in our hand, and we can feel the warmth. And in the wintertime, it's kind of nice. It's like a little hamster in your hand, turning that little warmth. Or you have your laptop on your lap, and you can feel the heat being generated as the electricity courses through all that circuitry and inevitably degrades into heat. On the scale of those devices, that waste heat really doesn't matter very much. But on the scale of the Science Museum, where we're using 6.3 million kilowatt hours of electricity annually, that electricity degrades into an enormous amount of heat. In large buildings, large institutional, commercial, and industrial buildings, they have to manage that heat. Because if they don't, the interiors of buildings would quickly become uninhabitable, and people would have to flee. So what do we do with that heat that's generated within buildings? Well, the standard procedure for years, decades, has been to throw it away, get rid of it, expel it from the building, and then use other forms of energy to do work that could have been done with the heat energy that we just threw away. So we hired Dave Solberg to do an exergy analysis of the Science Museum. And after a few months of doing calculations, he came back and he said, here's what I've learned. All that electricity that goes to the Science Museum, it eventually degrades into over 20 billion BTUs of heat energy. And we said, well, that's just kind of a big number. That doesn't really mean anything to us. And he says, then you throw away that heat energy. We said, yes, that's how the building was designed. That's how we operated. He said, but then you buy 15 billion BTUs of heat energy annually. So why are you throwing away all this heat energy and then turning around and buying it from somewhere else? And we said, well, because no one had ever presented it in those terms. So working with him, we did a heat recovery project for the Science Museum, and we installed equipment that now allows us to capture heat energy from portions of the building where we do not want it and move it to areas of the building where we do. So here's your one and only multiple choice question of the morning. The Science Museum of Minnesota has reduced its purchases of heat energy by how much through its recent energy efficiency retrofit? And I'm not looking for a show of hands. You can just think of the answer in your head. A, 25%, B, 33%, C, 50%, or D, 67%. And we have, this process has been up and running for 2 years now, and we have actually reduced the heating load of the Science Museum by 2/3. So on a cold winter day, the vast majority of heat that we use to heat the building is actually generated by the building itself. Of course, you have to spend money to save money. So we spent about $900,000 to do the retrofit, which gives us a payback of about 4.5 years. And at the same time, we employed factory workers, truckers, riggers, pipe fitters, cement workers, all that doing this retrofit. So we are encouraged about this, and we'll be sharing it more widely with communities around the metro area in the hopes that more institutions will implement this kind of changes. So let's take a look at another scale of innovation at the region, at the state of Minnesota. Minnesota, we can take great pride in the fact, is taking a leadership position on energy and on clean energy in the United States. And in particular, last summer, Xcel Energy announced plans to close down 2 of its largest coal-fired power plants. Not only are they here in Minnesota, but they're 2 of the largest in its entire 8-state service area. And just recently, it reaffirmed its commitment to do so and to replace this coal-fired electricity with an overwhelming amount of wind and a little bit of natural gas. This is going to dramatically reduce the carbon pollution in the state of Minnesota. And now at the global level. So there was this conference in Paris, and when it finally concluded on Saturday the 12th of December with the striking of the final gavel, 195 nations, by unanimous consent, agreed to the following: to pursue efforts to cap warming at no more than 1.5 degrees Celsius, to halt the rise of greenhouse gas concentrations by the year 2050, expert review of national emission inventories, meaning that 195 nations have made commitments to reducing carbon pollution, but they can't just claim those reductions. They have to allow independent teams of experts to come into their countries and actually independently verify that the carbon dioxide reductions they're claiming are in fact real. And finally, there's a recognition that while this was an ambitious and signature international agreement, it's still not enough to ultimately stabilize global climate change. So, you meet every 5 years to establish even more ambitious national emission reduction plans. So, what's the role of the United States in all this? Well, to do more, better, and faster. And the good news is that there are remarkable changes underway. We are actually in the midst of the clean energy, renewable energy revolution that we've been talking about for years, decades. It's actually underway right now. So, since the 2008, the cost of LED lights, for example, have dropped by 90%, and the number of fixtures in the United States have increased by 195 times. In that same 8 years, the cost of solar energy has dropped by 60%, and the amount of installed solar capacity in the United States has increased 20 times. And in that same 8 years, the cost of wind energy has dropped by 40%, and the amount of wind capacity in the United States has tripled. These trends are all continuing. The cost of renewable energy and energy efficiency and energy storage are all continuing to climb, while the reliability, the durability, and the efficiency of these technologies continue to improve. We are in the midst of an energy revolution here in Minnesota, in the United States, in the world. And what we need to do is more, better, and faster. Because here we are. The future of this world, the future of Earth, the future of our only home planet will be determined by human decision making, either by default or by design, either by accident or by intention. So let's imagine, design, and realize the future Earth that we all want. And I greatly appreciate the opportunity to speak before an audience of people interested, engaged, and involved in doing exactly that. So that's my story this morning. Thank you very much. And I think we might have a time for a few questions before you get to go off and further explore the exhibits and other programs. So is there anything that you would like me to elaborate or clarify? Yes, Shannon?
Do you have additional upgrades or projects that are going to be coming underway for further energy efficiency at the Science Museum?
Yes, so the question is, are we going to be pursuing new energy efficiency initiatives at the Science Museum? And yes, I think we will in the next year or two. We know that, I pointed out that first statistic on LEDs. We have looked at what would be involved in replacing all the light fixtures in the Science Museum with LEDs. And it's something that we would like to pursue, but we need to wait until our new president takes her leadership role at the Science Museum in May before we can talk about implementation of that. And I'm personally very excited about that opportunity because the calculations are that we could reduce the amount of electricity by the Science Museum by half. 50% reduction in the amount of electricity. And then if we pursued some of these opportunities that are now arising to, for example, sign up for a community solar garden, I think the potential exists that through energy efficiency and through signing up for a community solar garden, the Science Museum in the next year or 2 or 3 could actually be a net zero carbon institution. I think one of the few museums in the United States to be able to make that claim. You had a question? Yes?
I have 2 questions probably. In my electric bill, I got a flyer that I could sign up for partial alternative energy.
Mhm.
I thought it was solar.
Yeah, probably. Because I think that wind source has been around for several years, and now there are now these opportunities arising both through Excel and through other vendors to sign up for community solar gardens. And I can't give you more specific information about that, but my wife works for Fresh Energy, and if you go to their website, they do have information on community solar gardens and the kinds of questions that you should ask as you get presented these options. Yeah.
I guess I have 3 questions. The second question is, I worry about the birds when it comes to the wind turbines.
Sure.
Has that problem been solved in any way?
Well, the question is about birds and wind turbines. And I think that, for example, as the wind turbines get increasingly larger, the speed at which they rotate begins to slow because they are spanning sweeping an ever larger area. And so I think that the issue of bird mortality has been very carefully examined in southwestern Minnesota, and I do not think it has been presented as a very significant issue. But I think that we'll always have to be looking at where in particular wind turbines get placed as we see them being put up around increasing areas around the country. But I would still say that it's an overwhelmingly, although there's no perfect energy solution, all these options of wind and solar are much significantly better than the burning of coal, which is, for example, in Appalachia, where we're cutting down whole mountaintops in order to gain access to coal. So in the scheme of things, I think that wind energy is a much greater environmental attribute than our current tact.
And my third question is about all the apartment buildings that are being built right around this area.
Yes.
And my imagination said, what if when they're constructed, they're mandated that
Yeah.
Is that something that could happen?
Well, I think every city has an option to decide how it wants to code or write the regulations for development. In my bio, Shannon read, I'm a member of the Urban Heat Island Network, and that's a consortium of the Science Museum, the University of Minnesota, and 2 other universities looking at this urban heat issue, and it's an important one. And because cities around the world are actually heating up twice as fast as the planet as a whole, because on top of heat increases due to climate change, cities are also heating up because the way we've typically designed, constructed, and operated the cities is with large amounts of dark surfaces like dark rooftops, which are very effective at absorbing solar energy and converting it into heat. And so I think that we need to be looking hard at how we make cities cooler in a global warming world. And it's important to start looking at how we minimize the amount of surfaces that we have in our cities that are very good at absorbing solar energy and converting it into heat. Question back here?
Yeah, you didn't mention ground source heating and cooling,
Right.
which is something that could fit into residential fairly easily without damaging trees.
Absolutely.
Do you see that increasing somehow in Minnesota?
Yeah, so the question is about ground source heating and cooling, and actually the Shannon mentioned in my bio the Science House building. So that's a separate freestanding building in our outdoor environmental science park that we call the Big Backyard. And when we designed and constructed that building back in 2003, is with the intention of the building being an exhibit in what was possible. And so we were very intrigued about the idea of whether it was possible to design, construct, and operate a building in Minnesota that on an annual basis generated as much energy as it used. So we designed the building with a photovoltaic and electric roof to make electricity from the sun. And the key challenge was not putting the solar on the roof. The key challenge was figuring out how to reduce the amount of energy that the building would use so that it was using no more than what the roof generated on an annual basis. And a key element to doing that was the ground source heating and cooling system. It's a very efficient way of heating and cooling buildings because you're using electricity to move heat energy as opposed to making heat energy. And increasingly there are ways in which to, there are now heat pumps that can move heat from in and out of air. You know, for example, a refrigerator is a heat pump. A refrigerator pulls heat out of the inside of that box and then dumps it into the surrounding kitchen, which is okay in the wintertime, but you're actually heating up the kitchen in the summertime. My wife and I actually installed an air source heating and cooling system because our house was built in 1923. It has radiators. It's very hard to retrofit to air conditioning. But there are systems now that put a heat pump on the outside, and we primarily use it to help cool different rooms of the house in the summertime. But it's a heat pump, so it can actually pull heat out of the outside air and bring it into the house. So we can use it both to cool the house in the summertime, and we use it in the shoulder season. So like this time of year, where the temperature outside isn't that much colder than the inside, but you don't want the house to be in the 50s. So we actually use that heat pump to heat our house in the fall and in the spring. Yes.
Two quick questions, Pat. One would be you were mentioning the revolution of innovation in solar, wind, and LEDs. I wonder if you could talk about what that would look like in the transportation sector in the metro in St. Louis Park.
Mm-hmm.
And then number two, how St. Louis Park can generate momentum in all the surrounding cities on these topics like Hopkins and Wilmington and things like that.
Yeah, I'll try to answer quickly because we're almost out of time. So transportation. So I want to touch on this in a couple of ways. One of them is that as part of this, being a participant in this Urban Heat Island Network, we have every year what we call the Urban Climate Institute, where we bring together researchers from across the United States to talk about urban heat. And the focus for many years on urban heat islands is how to minimize the amount of dark surfaces that absorb solar energy and convert it into heat. But one of the other sources of heat to urban heat islands is actually the tremendous amount of heat given off by our buildings and also by our transportation system. So think about that. You put a gallon of gas in your car, and maybe that propels your car 20 miles or 40 miles, depending on what your fuel mileage is. But all that energy in that gas eventually gets converted into heat. And look out at I-94 or 35 on a busy day with thousands of cars going by. They are dumping a tremendous amount of heat into the urban environment. So we're seeing increasing interest in electric vehicles. Electric vehicles are inherently more energy efficient than internal combustion engines, especially if we continue to green our electrical grid by using wind and solar as opposed to fossil fuels. But if those fossil fuels that we do burn, if we can actually use the heat energy that those plants generate for other beneficial uses. So for example, most power plants burn coal, and about 35% of the energy in that coal actually gets converted into electricity. The rest of that heat is just allowed to escape into the environment. District Energy St. Paul has a plant in downtown St. Paul that burns primarily wood waste collected from the metropolitan area to make electricity that it then sells to Xcel Energy. But instead of throwing that heat energy away, it puts it into an underground system of pipes that delivers that heat energy to buildings throughout downtown St. Paul. So those buildings are not burning fossil fuels to heat themselves. They're actually using heat energy that, in most situations, is actually thrown away. So if we combine our electrical generation both to electrify our transportation system and use the waste heat that we formerly were throwing away for beneficial uses, we could dramatically reduce the impact of our environment. And I just want to wrap up by saying that I'm very excited about the future. I know that we have enormous challenges in terms of environmental change, especially global climate change. But with the agreement that was reached in Paris back in December, and the innovations that we are seeing already underway, and the enormous commitment that I'm seeing both in the nonprofit, the philanthropic, the government, and the business community to do more, better, faster, we have an enormous opportunity right now to create a new economy future for us that is good for the environment, good for the economy, and good for employment. And I greatly appreciate the fact that St. Louis Park is taking a leadership initiative on doing exactly that. So thank you for being here this morning.